Okay, so we're going to switch gears now and head into space. This weekend marks the beginning of fall, but it's also the harvest moon.
That's right. That's on Monday. So joining us this morning to talk all about this time of the year is astrophysicist Dr. Paul Sutter. Always good to have you on the show, Dr. Sutter. All right, so the harvest moon, let's start with that. So it occurs 2 days after the autumnal equinox, which is tomorrow. So what does the harvest moon mean, if anything at all?
Right. So the harvest moon is, by definition, the first full moon after the autumnal equinox. It just happens to be a couple days after the equinox this year, so it's coming up on the 25th. And that's the definition. It has this cool name, the harvest moon, because it's going to hang out near the horizon for a few nights after that full moon. So it'll be big, it'll be bright. And back in the day, before electricity, that was really handy for being out in the fields and doing the harvest.
Yeah, it works out nicely. Now, let's talk about the instrument that NASA launched, the ICESat-2. You know, it's a laser that's going to help measure what's happening yes, the laser. I'm sorry, I neglected to do that. It's been up there, thank you, Paul, for about 5 days. How long is it going to take to get any sort of data back? And, you know, what are some things we're going to learn?
Yeah, this ICESat mission is so cool. I love its simplicity. It's just a giant laser. It's a laser the size of a small car, by the way.
Wow.
And it's not for destroying things. It's for measuring things. It's for science. And it's going to do multiple orbits over the Earth, returning data very, very soon, as soon as they finish testing, actually, to measure the height of oceans, to measure the height of ice, to measure the height of vegetation, to measure the height of everything, to help us get a sense of, as our climate changes, how do these relationships between the oceans and the vegetation and the ice change with that climate.
It makes you think, what else could we use lasers for, right? I mean, we always talk about studying other planets and could there be life? Yeah, right. So what else could we use lasers for to learn about space?
Lasers are an incredibly useful tool in many kinds of fundamental physics, in biology, here in earth science. There are actual lasers created by nature itself, but not in visible light, but in microwave. So we call them masers for microwave. And there are giant gas clouds hanging out in the Milky Way galaxy that emit lasers of their own.
Yeah. We only have about 30 seconds left here. Let's talk about that massive dust storm that blanketed Mars. You know, do we know anything about it? Did we learn anything about this dust storm?
Right. This was a massive storm that raged across Mars all summer long and completely covered the entire planet with dust with the consistency of talcum powder. And the Opportunity rover on Mars, which is solar powered, shut down because no sunlight, and we're trying to reestablish contact right now.
He's like little windshield wipers off, you know, its sensors. Yeah. Just like that.
Paul, always love having you. And by the way, when he did this with his beard, I definitely thought of Austin Powers with his cat. You know, he like kind of did that with his cat, so that fit in nicely.
Oh, fit nicely with the lasers. Or the masers. Masers.
They should have named that laser, by the way, Austin Powers, or the name, what was his cat name? Doolittle. I forgot the name of his cat.
You remember all that stuff. All right, Kelly, let's go coast to coast.